Hello and be welcome to the first episode of Let's Develop Code Kata. Code Kata, a small programming exercises meant to practice our programming skills. So they're usually quite simple tasks in themselves that allow us to focus on the development techniques and methods. The term was probably first coined by Dave Thomas, the co-author of the book The Pragmatic Programmer, and it is borrowed from the Japanese concept of kata in martial arts. So the idea is to have a simple task and repeat that simple task over and over and over again to get the practice and the skill you need to execute it really correctly in a real fight, or in our case, in real programming. So what I want to do today is, as a starting point, a very simple code kata, which is called the FizzBuzz Kata. I took that one from codingdojo.org, but I know that it's available on various websites and I've seen it in various occasions, so the FizzBuzz thing is really widespread. But it's a quite simple and small coding kata I'm pretty sure I'm able to complete in this episode, which is why I choose it. Okay, so let's talk about the problem that I want to solve. Imagine the following scene. You're back in school and it's 5 minutes to the end of the class when your math teacher decides that you should make a fun game to improve his math lessons. And he explains what's the point of the game. You're going to take turns in the class, so one pupil after another, and you have to say the next number in a sequence, starting from 1, 2, and so on. And the fun part is that if you come across a number that is divisible by 3, you say fizz instead of the number. And if the number is divisible by 5, you say buzz. And this, of course, applies if the number is divisible by 3 and 5, you have to say FizzBuzz, hence the name of the kata. So, this goes in turns, and it turns out you're very bad at that. So you decide to write a program that helps you the next time. So our task is to implement that very simple game. Usually for the task is to implement it for numbers from 1 to 100, because probably the game won't go around more than like 3 times if I assume a class size of 30 pupils. And make it calculate our next answer. So let's get started. So I've already created an Eclipse project for me to place the kata code in, and I will publish that project to GitHub after the show for you guys to look at what I produced. This is a small Maven project, and all I did so far was adding JUnit and Hamcrest as test dependencies so that we can use them for test-driven development. And let's get started by writing our first test class, our first test, and therefore creating our first test class, which is called FizzBuzz Test, and which is going to be in Let's Develop Kata FizzBuzz. Create that one and write the first test. So what's the first thing I want to test in this case? Probably let's start simple. The FizzBuzz calculator should return 1 as a number, because 1 is neither divisible by 3 nor by 5. It should be returned as a number, right? First thing I want to do is call something on my unit under test, which is I decided a static method on a FizzBuzz class. Since the FizzBuzz class doesn't exist yet, I'm going to create it in main. The rest is okay. Yep. And I want to call a method get answer for 1 here, which doesn't exist. So let's create that method, public static void get answer 4.
quickly save that one, execute the test. Okay, the test is running. So I can do some small refactoring here, rename I to number, because I want to get the answer for the number, and I want to delete that stub comment here. Go back to the test. Test is running still, yep. Okay, next thing is I want to capture the answer, which I currently can't because the return time is void, so I can't use the quick fix I just wanted to use. I decided to return the answer as a string, so string answer equals FizzBuzz get answer. Now it doesn't compile anymore, so I want to change the return type to string, and for it to compile I return the empty string. Test still run, brilliant. So I can go on writing the next test part, which is actually my assertion. Assert that the answer is actually 1. Remember, I decided here to return the answer as a string, so I want to have 1 as a string. If I execute that, the test probably fails. Yes, it does. Easiest thing to fix that is this, right? Yeah, it is. Switch back. Test is running, so it might be time for refactoring. I'm content with that solution. There's not too much to refactor. I guess in this case, I want to inline like that. The answer, because it's too simple. It's simple enough for me to do that. I know that people argue about whether to inline or not the actual exercise of the unit code into assertions. For bigger code, for bigger tests, I would probably not do that. For this small one, I do it because I think it's easier to read. Okay, next test case. Test public void should return 2 as a number. Assert that again. FizzBuzz get answer as string for 2 is actually 2. This test should fail. Yes, it does. So I need to do something here to make it pass, which is, oh no, I cannot call toString on number, but I can do string value of number. Now the test case should run again, right? Yeah, nothing to refactor here. Nothing to refactor here. Let's continue for now, that's okay. Test public void should return, let's continue with a 3, which is actually divisible by 3, obviously. So it should return fizz, right? Fizz, assert that FizzBuzz get answer as string for 3 is fizz. This test doesn't work, so I can adjust my production code, or I should, and say if number equals 3, return fizz. Save it, execute it, test running. Implementation is okay, no need for refactoring. But actually now I want to do some refactoring on the test side. Because I think that I can actually improve readability of these tests by introducing helper method. So let me quickly pull out the matcher and pull out the number here. Yep, number matcher, and then define a helper method for this part here, which is assert that answer for number is matcher. And now I'm going to inline this again real quick. So I have assert that answer for 1 is 1. And now I want to use that thing for the other. Oh, wrong. That was my helper method, which I want to move down to here actually, and I want to use this new helper method in the other two tests. Assert that. It's a bit shorter and I think it's easier to read. So I'll do this refactoring, re-execute the test. Tests are still running. And yeah, with that, I'm content with the state of the code. So I continue with the next test case. Let's do another one for divisible by 3, which might be 6 actually. The next number that's divisible by 3. Execute the test. Test is failing, so we have to adapt here. Easiest thing is probably modulo 3 equals to 0, which should make the test pass. Yes, it does. Now I could refactor, but for me that's okay. I know that some people would maybe extract this condition into a helper method, but I think that the pattern modulo some number equals 0 is familiar enough to most programmers that there's no need for that refactoring right now. So I'll continue with writing more tests. Let's say next test case is probably going for the 5 rule here. Should return 5 then as buzz. So 5 is buzz is my test case. That test case is failing. So I can add more logic. If number equals 5, return buzz. You see them really doing baby steps here, but it's to practice test-driven development methodology, so baby steps is what we want to do. Next test case. I don't think there's anything to refactor. Let's try a multiple of 5, for example 10. It's not working, so I adapt my logic here and say if it's divisible by 5, I return buzz, which makes the test pass. Again, quick thought about it. I don't really like that there's multiple exit points here now, so it's hard to see what's actually returned. So what I'd like to do here is pull that one out into a variable, let's call it answer, which is by default the number as a string and which is overwritten here, or now need an else if here, or here, and returned in the end. So that should still let the test pass. And now I have only one exit point, which is at the end. And actually I also like to have the braces here, even if it doesn't make a difference. For me, it's easy to read that way. Okay, so tests are running, right? Go back and write the next test case, which is probably a test case about a number that's divisible by both 3 and 5, right? So should return 15 as FizzBuzz. FizzBuzz and 15. And now go here. So yeah, let me add the case. I have to add that case at the beginning because each number that's divisible by both 3 and 5 is of course divisible by only 3 and only 5, so it would enter these cases down here. So I say first case number equals to 15 actually. That's enough to make my task pass. Answer equals FizzBuzz, and add an else to the if, execute the tests, makes it pass. go over here, add another test case, should return next common multiple is 30 probably. 30, so I could do the same here, say modulo 15 equals, oh, I forgot to execute the tests actually, equals 0. So let's undo that real quick and execute the tests. Yeah, the test is actually failing. Now I execute my solution, re-execute the test. Okay, test passes now. Time for refactoring. One thing I don't like about this implementation currently is that it's implicit that this case here is actually common multiples of 3 and 5. So someone that goes here later could change the order of these cases and actually break the program with that. So I would like to make that obvious, and I think the best way to do it is to introduce helper functions now, like is multiple of 5 down here, and an is multiple of 3 here, and then use that one. My test should still be running, right? Use these two helpers up here. So if is multiple of 3 and is multiple of 5, then I go to the FizzBuzz case. Should still be running, right? And now I can see that this case must be on top, because otherwise a part of the condition will be fulfilled, or part of the condition is always fulfilled by those two. So it's more obvious that if I change the order of these cases, I might break things. Okay, is there anything else to test? Yes, actually, what about negative numbers? So I'm pretty confident that this is working for positive numbers, but I'm never sure how Java actually behaves, or modulo actually behaves for smaller numbers. So I actually would like my program to not return anything for 0 and below. So I say should throw for 0, which is my first test. This is like the border. Here I can't use my helper method because I expect it to throw an exception. So I say FizzBuzz get answer for 0. I don't need to save it, but I want to add an expectation here, which is an illegal argument exception. Currently that's not the case, right? So this test is failing. So I say here if number equals 0, throw new illegal argument exception, number smaller 1, and make this close, re-execute. This actually works, but now I don't like the program that much, because it's doing two things in this one method here. First is checking the argument, second is computing the answer. So I want to at least draw that out and say check arguments. And actually then I want to pull this out into another method and say compute answer. Still running, yes, still running. And then I might inline this here on occurrence. Right, still running, still running. And because I like the newsletter style, I'm going to take this one here and actually move it down to somewhere around here. Then check argument, compute answers, and helper methods down there. Okay, this is working, so I want to have the next test case. Copy, paste, illegal argument exceptions 4 -1, just to make sure that it's the same for negative numbers, which it currently isn't, right? Yep. So I want to adapt the check here and say smaller or equals to 0 throws an exception, which makes the task pass. Okay, let me have a look at that. I think I'm content with the state of this implementation. There's nothing I'd like to refactor. But when I have a look at the tests, then I actually think it's quite many tests, and they all have only one line. So I guess for the sake of readability and ease of understanding, I would like to refactor the tests a little. Because in fact, there are always two tests for the same category of output. So there's two tests for returning normal number, two tests for returning fizz, two tests for buzz, two tests for FizzBuzz. And I'm going to group those into one test class. Should return number if not divisible by 3 and 5. My first test case, so this one and this one. Can delete this here. Should return, let's execute that. Executable should return fizz for multiples of 3. This one, remove, re-execute works, should return buzz for multiples of 5. I know there's people saying, I think even Uncle Bob in the Clean Codebook, for example, that there should be one assertion per test case, essentially as a rule of thumb. But I really think that for these cases where the test is that short and I have these categories of tests for the different types of outputs, I really prefer to group it, because then I think it's easier to understand what the tests actually do, and easier to see that I captured all the different cases. But maybe that's a special thing for this very easy implementation. So should return FizzBuzz for multiples of 3 and 5. 15, 30. Okay. I actually can't do the same for the exception tests, because if the first one throws an exception, it would never execute the second. So I want to have the two test cases here, but it's quite much shorter, the test right now. And as I said, I'm convinced that it's easier to see now that I have these different test cases. And maybe just for the sake of completeness, to ensure that I didn't do something wrong from 3 onwards, I'm going to add a test for 4 here, which does not pass, in fact. Okay, because I passed the wrong argument. Okay, so it passes. Okay, if I did that, I should probably 5 and 6 are out, so I should use 7 here too, just to ensure that I did not break anything around the first multiples of my 2 divisors, 3 and 5. So let's re-execute that. Still working. Okay, I guess that's it for this kata. I haven't had a look at the clock, so I'm not quite sure how long it took, probably around 20 minutes. I hope you liked it, could take something from it. If so, give me a thumbs up on the episode. If not, If you have any comments, any feedback, any critiques, any ideas, feel free to drop me comments, send me a message. If you have other ideas for coding katas or know other katas I should do, then send me a message also, please. And I hope to see you next time.